Hey guys, welcome to this video. This is going to be a quick tip. I'm working on a larger project here, and I figured I came across a problem where I need to unfuse my vertices after fusing them. This comes in handy when you have some geometry. You have to fuse it to run some operations on, but then you need to get back to your original geometry. And that is where Unfuse comes in. So this might not work in every scenario because all these are pretty much individual lines and they are a network, but I'm pretty confident you can adapt it to a different situation. So right now I'm going to store ptnum and the IDY on the unfused graph, or the unfused geometry. I'm going to, this isn't necessary, we can skip this step. And we make we gather the points of, so for each primitive, we get the vertice and we get the point of the vertice, and then we store that in a graph map integer array attribute. And so we just store that here. So right here, as you can see, we store the graph map. So that's the original. So when it's fused and those points are destroyed, the primitives know their original points, and that's pretty much it. That's the trick. And so this unfuse, this might look a little bit more daunting than it actually is. So there's a couple steps. I'm just going to walk through the big picture. We want to grab all the point attributes of our unfused geometry, which is 1. And we want then, as you can see, this is detail we're only running over once. That's very important. We're going to add an origin point attribute to build a link between the unfused and the fused geometry. We're going to loop over all the primitives. We are going to get the graph map attribute. For each primitive, we are going to get the current points. On there, we're going to, from the current point data, oh wait, no. Okay, we're going to store this current point data. We are going to use the values from the graph map to look up the IDY attribute on the unfused geometry. Remember, we're running this on fused geometry. This is unnecessary, but this was for a debug primitive before I realized I have to copy all the point attributes as well to get back to the original geometry. So this gets the position from the unfused geometry. This adds points to this fused geometry, and these are essentially, at this point, they're just floating in the air. We've just created points on the positions of the geometry, and so the attributes don't line up. So this is how you copy all the attributes. You want to loop through, we grab the point attributes, and this is a detail intrinsic, which you can see here. This just is a string array of all the point attributes on the unfused geometry. And for each one, we want to get its type, and then we test whether it's like an integer, a float, or a string. And then so we can query the values from the unfused geometry and then set the new point that we created. We can set the attribute. As you can see, this new point 1 lines up to new point 1. So we are grabbing from our queried point the value, and then we're setting it to the new point. And in here, this is a float. This is triggering if it's float. And then we test the size of the attribute, and if it's 3, we know it's a vector, so we can assign the vector. And so all the attributes assigned, but the primitives need to be have their geometry switched. So we're going to set the vertex point to the new point we created right here and here, and you can see this is our primitive, this is our vertex, and this is the new point that's been created. We want to remove the old points, and that's the current point. because we've reassigned the primitive to the new point. And then we're going to store the origin attribute so we can build a quick map back to the fused geometry. And that's it. And I will put the location of this code on GitHub, and you guys can download it, maybe make some optimizations, do whatever you like. Thanks for watching.